Hey guys, let's take a look what's hitting the bench today. This is a EICO model HF-12. This is a integrated amplifier, and so it has bass and treble controls, and you have inputs for auxiliary tuner, phono, and tape head, and it has volume. And this is a mono amplifier, so it does amplification of one channel from these different inputs that we have, and it has connections in the back here for actually a single speaker. It depends on what the impedance speaker it is you're using in terms of which of these connections you utilize. And first thing to notice is the cord's been cut off. Alright, so we all know that's actually a good sign. That means somebody's telling us, don't plug this in, there's something wrong with it, until you take it to a tech who can open this thing up and fix it or scrap it or whatever needs to be done with it. So, is this mine? No. This is from a guy I met that asked me just to take a look at it to see if there's something seriously wrong with it. I told it there probably is because of this. I'll suspect that maybe there was a problem with the power transformer, but we'll just take a quick look and see if we can see what the glaring issue is, and then I'll just let him know. I doubt very much that we'll be repairing this, but I thought it'd be interesting to open this thing up, piece of history, and see what's inside. Now these were sold as kits, so as we get in here and look at it, you know, this has been wired up by a hobbyist, and there may be problems with the way it was wired. So if there's something that's been blown, it could be because it was wired up incorrectly, and that may be very difficult to find. So it could be quite time consuming to find out how to fix this. But these are pretty sought after. You can put two of these together and have a stereo, and they're tube amps, and they have a very good reputation. So it might be worth somebody to do that someday. But anyway, let's just take a look and see what happened to this thing. And so what I'm planning on doing is opening this up and checking the power transformer windings and just see what we have there. Then after that, if that all checks out okay, there is a sheet in the assembly manual for this, which is available online, that has kind of a last checks kind of paragraph that allows you to check a few things to see if you're getting right impedances and so forth at different locations before you plug this thing in. So if the transformer checks okay, I'll go down and check that list to see if it has anything new on it to check, and then we'll just explore together what's the deal with this deal. Alright, so hang on, we'll get started. Okay, so we got two screws in the back. Okay, that went the same way as the screw from the GE. Okay, this is not a first look. I took a look at this in the parking lot when he handed this off to me. Alright, but I have not taken the bottom off, so this is all I've seen. This dust bunny paradise in here. Let me zoom in, you can take a closer look. So you can see where some of the components have been labeled on the back for the wiring purposes. This appears to be the power transformer because this is where the wire goes in. This would be the audio output transformer. It's here by the outlets for the audio stages. And this is a push-pull amplifier. I'll pull up the schematic and show you it too in just a minute. And looking at it on the first part, when looking at it from here, I didn't see any problems. I can't get to the transformer windings from here anyway, so I'm going to have to flip it over and go in from the back, and that'll be new to me to see what's in there. So let's take the bottom off rather. Stuff is falling out of it. Let's see what we got. Missing a foot in the back. This thing had non-polarized plugs, so I believe people had problems with hooking in things through these switched or that switched or unswitched outlet and blowing fuses. This doesn't have a fuse in it, so whenever this gets repaired, if it does, it will need one installed. And if it turned out to be a blown transformer, that would have saved it. Okay, first look inside from the bottom. Did I speak too soon? Maybe I did. Got another screw. perhaps. Let's see. No, it's just shoved in there. Okay. Let's see what we got. I'm looking to see, first of all, if I see any evidence of damage or something that's blown up. Okay, the power transformer is here. You can see this is where the cord comes in, and then there's a line that comes over here to the external socket. Does this have an on-off? Presumably it does. I guess we'll find out. Okay, starting at the power transformer, I don't see a problem here. You know, in terms of catching fire, it didn't look like that happened. I tell you, looking at this, I don't see anything that has gone wrong. It doesn't mean that it's not got an internal short, it just didn't cause a burn-up problem. Maybe it's drawing too much current or something. Okay, I don't see anything obviously wrong, so we're going to do some checks. Okay, I got the screw that was dropped. Okay, so there's a manual available online for this. And in here, I'll put this up on the screen in edit because I know you can't read this. But basically, we're going to be looking at page 15C, final steps. If you have a voltmeter, check the following resistance checks before connecting the AC line. So we're going to check that first. Okay, check for a cold DC resistance of at least 2 ohms across the AC line plug. Well, that'll be checking to see how we're doing on the primary. So we'll get that connected. So that's connected to AC, as is this. All right. Got my handy meter here set on ohms. .7 ohms. Check to see a resistance of at least 2 ohms. So it looks like that's a test okay. So the primary looks pretty good. Let's take a look at the schematic here. So we just tested this element right here. C16 may be short. Before we power this up, I'd probably want to just cut that lead since I'll have this on an isolation transformer. I bet you that's that bumblebee capacitor. And that's what you call a death capacitor right there, right? Because it'll go straight to chassis. And there is a switch somewhere. There's a switch 2. Okay. So now we're going to check there's a 3-pole secondary here, so we can just test leads 1 and 7 and go into the rectifier tube. Let's see, and then these other 2 go on either side of the hum potentiometer, whatever that is. Do you want a lot of hum or you want just a little hum, I guess? All right, so we'll check, since we just checked this, we'll see about checking pin 7 and pin 1 of VC6. And we'll see if that isn't what it just told us to do. Pin 1, pin 7 of XV6. Alright, so where's the rectifier? Is this it here? EVZ1. So this is the power rectifier. And so we want to check the, was it the ohms? Yeah, because we're checking windings. So we want to go to 1 and 7. Either side of the index. Well, there's the index, so that's 7 and that's 1. That is in megohms. Alright, you want to have check for resistance of at least 65 ohms between ground and pin 1 and pin 7. Okay, let's go to ground. There's ground. 138 ohms. So that passes. $519,000 ohms. because this is megohms. 1, 2, 3. How many pins? Is that a 9 pin? 7, 8, 9. That's a 9 pin. So I did this incorrectly. Let's try this again. Okay, here is the correct pin 7. Okay, that's fine. That's the 149, and this one was 139. That's much better. I was connected up to the wrong post. That's a 9 pin, not a 7 pin. All right, so now what we do is go to 3, 1, 2, 3 here. That's over a meg. It's supposed to be at least 40,000. Those two are tied together. These are the ones that go on either side of that adjustment. Uh-oh. Okay, that is... I should be looking at the filament string here, and I've got a bulb in here. Let's see here. Let me just get the black off here. That should be measuring the. Let's measure the resistance directly across. Let me see. Problem is, you're getting resistance across all the filaments in parallel, so I mean there will be low resistance. This would be more suitable for measuring voltage here. Well, it's not a short. Okay, so I'm going to maybe risk that. Okay, let's go to a low voltage power up on the variac and the isolated supply, and see what we get here. Okay, so there's ground. We were measuring for AC voltage going to the plates of the rectifier tube, which is 1 and 7. So here's 1. Okay, I've got 60 volts going in, and at pin 1 of the rectifier tube we have 164 volts. At pin 7 we have 164 volts. Let's look what voltage we have across the bulb. We've got 2 volts across the bulb. So since we're only at 60 volts coming into the transformer, that might be close. Can't tell if it's got a glow to it or not. Okay. Well, I've had it sitting here on for a few minutes. It's not probably long enough for a capacitor to reform, but I'll turn the voltage up a little bit more, see if we get anything happening. How far you want to go? 75? I don't see any glow. I'm pulling 1.2 watts. So it's pulling something there. Still 2.5 volts at the bulb. Ain't connected to anything. What's going on here? Getting 0 volts on either side of the bulb. That should be reading directly the filament voltage. Could be we got a tube shorted out. I'll turn this off and I'm going to pull the tubes. Okay, I've got the tubes out back here. So, let's see. I'm just going to check to see what kind of resistance we get across the winding for the filament part of the transformer. So what I'm going to do there is go and measure ohms, and I can check it across the connections to the bulb. Looks like the filament side of the transformer is blown open. No, got something now. Okay, I have 168 volts. So let's see. So I may have a shorted tube. What I'm going to do is check the tubes now. At least check them for shorts, I guess. Okay, so the tube complement in here is the rectifier is an EZ81, and then there's 3 12AX7s, and then there's 2, this is a push-pull amplifier, there's 2 EL84s here. What I'll do is I'm going to go ahead and check these, mainly for shorts, but while I have them in there I'll just go ahead and check them, and then when I get done, if I find something interesting, I'll show you. Okay, we're set up again. I've brought all the tubes back in, except for the rectifier tube, and I tested the little pilot light was burned out, so I replaced it with a new one, number 47, and we'll see how this goes. So I'm going to turn the voltage down again, and make sure the switch is off. Depth capacitor, by the way, is on the other side of the on-off switch right in here. It's still connected. Alright, so power on. And turn up the voltage to, say, right in here. Nothing on the dim bulb. Yeah, I think the filament winding is shot on this transformer, because I'm measuring. So let's just double check everything. This off. This off. Here we're going into the primary. Primary's got 90 volts, which agrees with what's coming in out of my little panel here. All right. I'm getting 90 volts here. Yep, 90 volts. Power switch is on. Then we're going to check the 2 plates of the rectifier tube, which is here, and those are pins 1 and 7 to ground. Take that off, go to ground. I mean, I'm assuming that's a good ground. Pin 1. Yeah, 250 volts to pin 1. To pin 7. 250 volts, so there's probably close to 500 volts between the two. 493 volts between those 2 points. So the rectifier winding secondary on the power transformer is okay, but we have 0 performance out of the filament winding, and I'm checking that by looking on both sides of that light bulb socket right here. I can go back to that by doing this here to here, and then testing here and here. Nothing. Sorry to say the filament winding's dead. And we're pulling 1.7 watts. That's probably just going to the good winding that's there, but this other one's dead. No. Now I'm afraid our friend's filament winding is shot. Okay. Well, I'll button this thing back up again and let the guy know that his transformer's burned up on his secondary of his filament. So what could have done that? I don't know. A lot of things, I guess. He wants to go to sleep. Alright, bad news. We got a part set, I guess. Okay, so sometimes it's worthwhile doing some poking around, even after you kind of give up on something. So what I was doing is I've been checking to see what the output of the filament winding is for this. And I've been checking it at one of the other sockets that runs off from one of these pairs of brown and black wires. Ran up to, and actually I was going to the bulb socket because I could see that the 2 windings came down in here, and it was kind of hard to get to that bottom one back there. And I was looking at it, looked like it was kind of, you know, you can see where the flux had gotten into the insulation and so forth. And I got to looking at it. But anyway, I just went back in there and I was trying to understand how the connections were to this, because I was worried about this hitting the cover here. And I noticed that the wiper is actually that yellow lead that you see in there. This actually goes to the wiper. It's down right in back behind here. You can't really see it from where I had the camera set up, but it's behind this lug is where the wiper goes. So the other lug, and it has a brown wire going to it down here, is the other lug for the potentiometer. And as I get to looking at this, look what I see here. The lead from the filament winding of the transformer is not connected. It's loose. So I've got a lead lifted here. I'm thinking about trying to see what do we have in terms of coil resistance. Now that I know it wasn't connected, well, that might be our open winding, right? Is an open connection, because this isn't connected to that brown wire. So let's do a resistance measurement and see if our winding is really open or if it's just wasn't connected. Would somebody have cut the wire off and put this in here without realizing that his solder connection had come loose? Let's see. Alright. So what I'm going to do is hook up lead here. And then my black lead here. Clip like so. And we'll connect it up to this other lead. That's not open. That's not a lot of resistance. I might have expected to see more to have such a low, I don't know. Actually, no, it would have fewer windings. That's right. We may actually have a good filament winding on this transformer after all. It was just came disconnected. Alright, so I think what I'm going to do is solder that connection back on there and then go back and see if this thing wants to work with glowing. I'll pull the rectifier tube back out, see if the glow, and then we'll see what we do next. So let me get that lead soldered back in, and we'll see what happens next. Okay, so what I'm doing now is I've set up to measure the voltage on the secondary winding, the filament winding. Since this lead isn't connected, as far as I know, this is the first time I've connected to it directly. It's a lifted lead, so I can now verify the voltage coming out of the filament winding of this. I've pulled the rectifier tube out, so I know that this isn't going to allow a B+ to develop. So I should be able to measure a voltage here for the filament winding. It should be about 6 volts. So let me back you up. Okay, so here will be the AC voltage going into the primary, and then this will be the secondary voltage for the filament winding. And the plate voltage is going to the plate for the rectifier tube, but it's not in. So let's just see what we get here. Get the voltage on the variac turned down, dim bulb is in. 30 volts. See if we're getting any current draw. Not yet. Okay, I'm not getting voltage through to here. Let me see what's going on here. There, we got voltage coming up there. And looky here, we're getting voltage appearing out of the secondary. This is very good news. This is very good news. We thought we had a blown secondary. Instead we had a cold solder connection that had come loose way down where you couldn't see it. Lesson learned. Lift the lead. Of course, that's with no load. Excellent. Okay, so what I'm going to do is solder that connection back on and go back and leave the rectifier tube out, and then we'll see if the filaments light up on all the other tubes. Great news. Awesome. Man, I'm not going to show this video to anybody. Everybody's going to say, man, this guy sucks. It feels like it sometimes. Let me make sure that thing's still good. Yeah. There. Got it well and truly folded over on there. Can you see it? It's right there. It's folded over very well onto that connection. I'm going to have to check these other connections to make sure they're not. This one I was worried about sticking up too high and hitting this bottom cover plate, and I'm still worried about that. I might ought to try doing a little surgery on it too, but let me get this other thing soldered in first. Then we'll worry about this guy. Okay, I think I've got a good connection there. It's not going to just fall off. Yeah, that's on there really tight now. Okay. Just a little dab of RA on there. This is such an old solder joint. basically reflowing it. Okay. I think that's solid. Okay, I'm going to get this kind of just a little bit down out of the way. There, I think that'll help, and that separated it from the wiper lead quite a bit too. Well, guys, what do you think? Think we got a chance? I do. Let me get all this set back up, and we can hook up the power to it again and see what we get. Okay, I'm set up for measuring input voltage coming into here. That'll go into the primary. I'm going to be measuring the filament voltage over here on the bulb that's right here, and we'll see the filament voltage here if all goes right. So once again, we'll turn this down really low because this is the first time I've actually had voltage applied to that circuit, I guess. So here we go, low voltage. Starting off pretty low. We already got 1.5 volts out of the filament winding. Turn up the voltage some. This out of the way. We're getting filament voltage. There's no capacitors on this circuit. So really what I'm doing is just making sure there's not a short somewhere in the circuit we haven't identified yet. And there's virtually nothing happening over here. We got 5.4 watts. Let me see how many amps we got. 130 milliamps. Yeah, 120 milliamps. Well, I'd say this is looking okay. Turn it up some more. 4 volts out on the filament. We have filament glow. Maybe too hard to see, but we've got glow in the base of the output tubes down here, and I can see glow in the 12AX7s. Cut this other light off. I don't know how well this will work. Not worth a darn. Total darkness. All right, well, you have to trust me. Watch your eyes. Here comes a bright light. So I definitely have filament glow on the 2 output tubes. And I think I see it on the 12AX7s. I think. Well, what do you want to do now? We put rectifier in and start to see if we get plate voltages. Okay, before I do that, I'll hook up a load on the output. I think I've got an 8 ohm resistor I can plug in, and I think I had an 8 ohm power resistor. And we'll see how she does then. Very hopeful sign. If I can get this bulb out here changed. I know I've got power going to this. But I don't have a rectifier tube in. Just stay clear of those posts. There's a 47. Alright, you know what? I'm turning it off. I don't want to come across 600 volts right there. I always put bulbs where they're hard to get to. Look there. Light coming off. We got bulbage. We got a light. We got an on light. And I'm telling you, we got some tube glow. Okay, watch your eyes. Alright, so I'm going to shut this down and I'm going to put the rectifier tube in and get set up for bringing up the voltage really slow. This will be the first time it's actually had, if the rectifier is working, voltage getting through the plates. So I'm going to have to bring it all back down again and watch out for old capacitors and things like that. So I'm going to take some time to make sure I got set up properly. Okay, so I've got the isolation transformer set up with a variac. We'll be measuring the voltage coming into the set here. This is the in voltage. I've put a load on the 8 ohm. This goes around actually the 8 ohm tap in the back because this wouldn't come together. That is a 8 ohm resistor, good for 20 watts. It's a 25 watt amp, so that'll be fine for what we're doing. Alright, this is set up to measure, we're going to be measuring plate voltages. Okay, so it's set up in DC because it's going to be looking after the rectifier if the rectifier is working okay. We know that the voltage going into the rectifier without the rectifier tube in there was good. We checked that before. So these are the two big leads I have set up for this guy right here. So I may be moving it around. I've got some voltages on a chart here I might check against if I get into that much detail. But meanwhile, I just want to see if mainly we start to see something happen because I've got old capacitors in here, and so I don't want to push our luck in terms of trying to do anything too fast. But we'll see what we can get. I'll just start up here. Alright, so I'm going to start low. The bulb is in the system. I know I keep moving in front of you, sorry. Alright, so here comes AC into the inlet. .75 volts in, 220 volts out of the plate of the rectifier. It's kind of different not working on a radio. It's got a speaker attached. You start hearing hiss and static and all that. We don't really see what's happening. I may change that load to something before too long and maybe put a signal in. See if we get anything out of it. You know, part of what I might be doing is just hook up a signal coming in and a speaker out so we can hear if the thing is making any noise and working. Clearly, this thing needs to have, you know, there's a bumblebee capacitor right there. It needs to go. There's another molded capacitor there. It's got to go. I'm sure we're going to get hum out of this capacitor here. So I'm sure we're going to have hum and all kinds of racket coming out of here. But I'm just trying to see if this thing will work at all. Then it's going to need to be, you know, worked on before it's really returned to service. I'm just really trying to see is the bare bones there. At this point, I would say yes. I've got the transformer working. There's really not much else to be looking at except maybe the audio output transformer. Make sure it's okay. I may be getting up to the top of my variac because I've got the dim bulb into place. I may bypass it here in a minute. So 336 was the plate voltage we were looking for. So what I want to do, I'm going to call that close enough. I want to check to see if I'm getting things at the other plate of the other plates while we're there. Okay, so we got 300 on the plate of the rectifier tube. Let's go up to valve number 1. Valve 1, I believe, is up here. And I want to be on pin 1. I think we have performance. I think what I'm going to do is, what? I like having the dim bulb in, even though I'm low on voltage. I think what I'm going to do is maybe put a signal in here and put some on here so I can hear what we're hearing through the unit. Get that set up. Okay, so now I'm set up. Got a speaker hooked up. That's connected to the 8 ohm output. This is an 8 ohm speaker. And I recently got this. Thank you very much. I have a Bluetooth receiver here for input. Come here. I'm going through a box here for taking the stereo output and having a single line out. There's a network in here to give the right impedances back to the source unit here. And then this is coming in here to the tape out. I read that people say you can put in a program into tape out and get a signal. If not, I'll switch it over to one of these other leads and we'll try out the different functions. I don't think it'll hurt anything. Alright, I'm going to be set up to measure the voltage in. I don't really have anything else set up for measuring voltages right now other than that, because I'm just trying to see, if we're getting anything happening. So let's see what happens. I'll be bringing the voltage up slow again, watching it here. Let's see. I'm not measuring any voltage here, so why not? I know. I wired this up to where the switch is now in the circuit, so I've got to turn it on. So here comes the power switch. The light bulb came on and we're getting 44 volts. I got to be a little careful because I could be referencing ground now. This is hooked up to the mains, so the ground could possibly find its way through here. I just want to turn it so you can see this light bulb is on. Okay. Let's have a little more. And let me play some music. Let's see if we hear anything. Get enough voltage to get to conduct. I'm not getting any current flowing. I should. Oh, here comes the dim bulb. It's glowing now. See my current draw, my power draw is. I'm at 30 watts. Okay, I'm not hearing anything. So the question will be, is the audio output transformer okay? Okay, I think we should be hearing something if that input actually works. Let me try a different input. Let's see, what are they? Let's try auxiliary. Auxiliary would be that one. A lot of corrosion flying off of this as I'm putting this in. I'm getting 300 volts on the rectifier. See if the plug for the speaker isn't okay. I heard something. Okay. We're getting a ground loop. Good news is we're getting something out of the amplifier. Let me turn down the volume. That's not, let me try back into here. Volume up. Okay, music stopped playing for some reason. Okay, the volume knob is not affecting it. How about that, huh? I don't know what's up with the volume. Let me see if I can figure out what's wrong with the volume pot. Okay, that was simple. Going in through here, the volume isn't affected. This isn't affected. This is just to get into the amp, the actual amplifier, not the preamp part. So people were going into this with their integrated amp or their preamps and controlling the volume from that. If I go into the auxiliary, which is now working, the volume works great. Up, down. Need clean pots, same old thing. Bass. Just need to clean these potentiometers. Yep, treble works. Okay, get some cleaner on those controls, and then we'll be back to having a good party. Okay guys, so I've got this set up. I've gone through and put control cleaner in the control pots and done a whole bunch of this with them and so forth. And so I've got a CD player down here that's coming in. I'm feeding it into the auxiliary position on here. And I've got 8-ohm speaker hooked up. It's down here. It's an old Fisher. And we'll see how this thing does. So let me give it some switch on. Watch the power come up here. See how many volts I got. Okay. So this will come on because I have it after the switch. So turn this on. Bulb comes up. System power is coming up. Turn the volume down. Volume and on off are on different knobs. Okay, why don't we give it some signal? Turn the voltage up a little bit. Pretty good bass, I must say. Guys, I think we fixed it. Okay, so clearly this thing needs to be completely gone through in terms of the capacitors, checking the resistors, making sure the plate voltages are where they're supposed to be. It needs a dang fuse. We've had a bit of a scare now on that power transformer. And but otherwise, how about that, huh? I don't know when this was built. When this was made, I'll do some research to find out if I can find out when these were. I think maybe the late 50s. But anyway, there you go. all the same tubes. If it had a bad solder connection to one of there's a thing called a hum potentiometer. There was a cold solder connection that had come loose, and it was way down where you couldn't see it, and therefore then the thing tested as an open transformer, an open filament winding on the transformer, and the owner cut the cord and put it in storage for decades. We found it and fixed it. Alright, I'll let the owner know it works. It needs to be, renovated or whatever you want to call it, but recapped. But it's got all of its bits and pieces, and it works just great. So that was a fun one. Almost gave up on it. Actually, I did give up on it, but I came back to it. So there you go. Okay, so I'm about ready to put this thing back together again, and I'm, to get it back to the owner. And the question is what do you tell people about this? Okay, well, you tell them that this thing needs to be completely gone through, as I mentioned a minute ago. And I wanted to demonstrate one of the reasons why. Okay, you may remember I showed you. I'll show you again. I can pop it up on the screen, but if you remember in the power supply section of this, focus, right, good. See over here at C16? So these capacitors go bad. It's a known thing. And what they do is they become a short. There's that thing beeping again. It becomes a short. Now, if this thing gets plugged in to where these are non-polarized plugs, now granted the plug's been cut off on this, but somebody could put a plug on this, and they need to take this into a tech and have it done correctly, okay, or it's very unsafe. If that lead right there is the hot when you plug it in, you turn on the switch and hot comes to that capacitor. If that capacitor's gone to short, then now the hot goes directly to the case, right? This case is metal. So let's see what happens if I do this. Now you'll see I've got an input voltage of 117 going in. I've got, and by the way, don't worry about this. I'm using this for connection to the speaker down below. I'm just using a new cord. Okay, so here's my old meter, and that's what it reads as 0, right? It has that phantom voltage thing again. Okay, so I've got it connected. The black lead's going to the ground plane. Okay, so it's going to ground. Now these screws all go to ground. Now this has got, I think, a paint on it. Now how good this paint is, I don't know, but there's also a metal mesh top in the back, and there's metal exposed on the back of the case. Okay. So what I'm going to do is show you, though, what you have to the two power legs coming in. Okay. Now this is I had this on an isolation transformer, so neither one of these is really neutral in terms of the way a house is wired. But when you plug it in, one of them might be neutral or one of them might be ground. Okay. So I can go over here to my little panel I have over here. This is where I was able to put in I have a 1 amp fuse here. And I had this barrier strip tied in. Okay, so one of these, you're going to be looking here and getting this over here. So once again, the unit is on, and it's playing. If I turn it up, we got Lamb Lies Down on Broadway playing. Okay, so if I go to one of the leads of the power, I'll go to the one that's closest to me. Nothing really there. You see what I'm doing? Now I'm going to go to the other one. Zap. Okay? So that means that if that particular lead got plugged into the hot side of your wall, then if you touch this case, you would get 114 volts AC. Okay? this is what killed the lead singer from the Yardbirds, right? He had this problem with his amplifier, his guitar amplifier, and it's possible that this so-called death capacitor is what caused that problem. So as you can see, this is quite dangerous. Now whether or not you pick this up from the chassis just touching the paint, I don't know. I doubt it. We'll go to touch the paint. Touching the front cover here. Let's see, can you see me? You got over 100 volts right here on this brass faceplate. How about that? How about these screws? Back you up so you can see what I'm doing. Okay, got this connected to that second post. Go to the screw on top. It's got some corrosion on it. Zap. The other one. Zap. But this brass faceplate has got high voltage going to it. So doing all this to show you that what needs to happen is that capacitor needs to be replaced with a safety capacitor, so that if that capacitor fails, it fails open. Okay, and I believe that would be what's called a Y-type capacitor, because it's going from one of the lines to the chassis ground. So that would be a Y-type safety capacitor. A Y2 would be good for this application for residential use. I don't know that I have one of those around here. I don't think I do. Not in the right, certainly not in the right capacitance, so maybe it doesn't matter that much. But that's a good example of why these things have to be gone through by somebody that's a pro. Okay, I've got the power turned off on this thing. I'm turning it around. The top side, I wanted to let you see, I pulled off the power cord connections and show you around here a little bit. So here is the on-off switch on the treble control, okay? And here is that capacitor. This guy here is leaking so bad, as you saw, you were getting communication from one of these hot leads, if you will, through this right to the chassis. It's soldered to the chassis right there, okay? So this needs to be replaced, okay? And it's dangerous. I'm considering going ahead and cutting it. But anyway, I'm going to let the owner know what the deal is and let him decide what he wants to do. Here you can see the couplet, by the way. I was talking about that earlier. Maybe I did. I don't remember if I mentioned it or not. There's the couplet. So here is this is the treble control and on-off. This is the bass. This is the volume control. And this is the input selector. And I cleaned all of these with some contact spray when this thing kind of woke up. Also, these connections here, these RCA connections, need to be cleaned off to make them make good contact. And the inside needs a cleaning and all that good stuff, but it's otherwise it's all original. Okay, so what we've got now is I've got it turned on. This is the voltage coming into the system. This is that hot chassis that I was measuring just a few minutes ago. That's going between one of the leads and ground. That's the chassis. That's where you're going to put your fingers, right? So if I was not running on an isolation transformer and I had that plugged into a wall, I had a 50-50 chance which way I had it plugged in. These are the days before you had polarized plugs. And you plugged it in one way and you touch that and you get full line current. I don't have this at 117 right now because I put the dim bulb back in, so I have some current protection here in case something goes wrong with what I'm doing. All right, I spoke with the owner. He said, by all means, go ahead and let's get rid of the safety capacitor, not safety capacitor, the lack of a safety capacitor. This is the capacitor that goes from line to the chassis directly. So the leakage of this guy is what's causing this voltage that we're seeing in there. And to show that, what I'm going to do is I'm going to cut the lead to that capacitor and get it out of the circuit. Now what that might do is create maybe some hum or something. It's there for noise suppression, but that just needs to be replaced with a safety capacitor by whoever restores this. Okay, so I have music. So now I'm going to cut the safety capacitor, the depth capacitor out, and we can watch what happens to the voltage going to the chassis. I'm going to get it right here. And that's back to our phantom voltage. So that lead is now no longer touching. I may leave the capacitor in there so they can see that's where it was and that's where it goes. But we have a little bit of leakage from something else, but it's not 100 and something volts. So once again, this would be something that would be addressed when somebody does the recap job on this. But at least we're not at 106 volts or something like that. Alright, so now what I'm going to do is I'm going to button this thing back up. I'm going to leave the cord cut off of it, and the owner knows that, you know, whatever happens to this, it needs to be gone over by somebody that does a proper, you know, workover on this. Capacitors, fuses, checking things out, put a safety capacitor in there, and let's see if it still plays. Sounds fine. Working good. Let's put it back together. So there you go, guys. EICO HF-12. I've got it all boxed back together again. Please take it to a tech and have it done correctly. Don't just put a cord on here. Do it correctly. And thanks for watching. Hope this ends up in a good home. So sounds really, really nice. It had a really warm tone. Sounded great. I like it. All right. Take care. See you next time. Bye.